All right, this is going to be one of those phrases that you're going to hear over and over and over and over again, and that's the max and mins of a function will occur when the derivative equals 0 or does not exist. Right now, we're going to deal with the derivative equal to 0, and just to give you a visual of what I'm talking about, if I just have a function that's graphed, if you notice every time I hit a high or I hit a low, those are beautiful tangent lines, my tangent lines are going through a zero slope. Okay, so when my derivative equals 0, I've got to change in direction. Now, just because it equals 0 doesn't mean that I've changed direction. I actually have to change from a positive slope to a negative slope on either side, or a negative to a positive. And we're going to talk about that a bunch of times. But right now, what we need to know is that when my derivative equals 0, that's where my max and mins can occur. So we're going to take a function, probably something you've seen in physics before. We've got, this is your acceleration of gravity, got an initial velocity of 34.3 in meters per second, and an initial height of 12. That's where the 12 comes from. So I want to find my velocity and my acceleration as a function of time. Well, my velocity as a function of time is going to be the derivative of my position function. So that's going to be, you're going to use your power rule. The 2 times the negative 4.9 is going to be negative 9.8 t. Then it's going to be the power of 1, because you're going to subtract 1 from the power, and then plus 34.3. And then the 12, because that's t, it's now times t to the 0, and the 12 is going to go away. And then my acceleration as a function of time is going to be negative 9.8, and that's your acceleration of gravity there in meters per second squared. Okay, how high will the object go in the air? Well, I want to know when the derivative, this is a max, and that's going to be when the derivative v of t equals 0. Now, it's not, that may not be the only time, but we know that when we set the derivative equal to 0, that can be where it occurs. So we're going to put in a 0 is equal to negative 9.8 t plus 34.3. We're going to solve that, and we get at a time of 3.5 seconds. Okay, and then it wants to know, that's when. That is not how high, that is when. Okay, now I want to know how high it went. That is a position question. So I need to go back to my y of t. So I need to evaluate y at 3.5. And that's going to end up being, when you put that back into your original equation, it's going to be 72.025. Okay, the next question is, how long will it stay in the air? Well, that means it stops being in the air. When does it hit the ground? When it hits the ground. Well, that's asking for your height. So height of 0. So I'm going to set y of t equal to 0. And I'm going to say, when is that? So you're going to evaluate and find your t. One of the t's is going to happen in the negative, and you know that that cannot be, because you started from a height of 12. That cannot be the height that the time that you're looking for. So you find the second one. If you look at your graph, it looks like that, and I'm looking for this time. It would extend this way, but that's not relevant. Okay, so we're going to evaluate that. We're going to use our calculator. So that happens at a time of 7.334 seconds. How fast will it be moving downward the instant before it hits the ground? Okay, well, I need to know the instant that it hits the ground. So that's at a time of 7.334. How fast will it be moving? That's a v of t question. So I need to find v of 7.334. So you're going to put that into your velocity equation and evaluate it, and you end up being negative 37.573. Okay, so you can either answer it with the negative, or you can say 37.573 downward. Shouldn't be a surprise that it's a negative, because you started by throwing your object up, which was your initial velocity, which was a positive, but eventually gravity is going to take over and your object is going to continue to move downward. So it shouldn't be a surprise that that was a negative number. All right, so how long till it reaches 3/4 of its maximum height? Well, what you do is, I'm going to say y of t is going to be in my y1, and then in y2, I'm going to put 3/4 of the maximum height, which we've already calculated, which was 72.025. Now, you're going to need to adjust your windows and your calculator. So you're going to need to adjust your windows to be able to capture this. But you have this function, and then you have your intersection. Now, notice it says, how long will it take? There's two different ways of asking this question. It is implied by the wording of this that this is the first intersection. It does reach 3/4 of its maximum height on 2 occasions, but it's just like, how long till we get home kind of question. It's when you first get there. That's what it's asking. And then that ends up being at a time of 1.583. Now, I do need you to pause this, and I need you to try putting this into your calculator, try adjusting your calculator windows so it works appropriately, because you do need to practice all of these skills. All right, the next question is, when is the height 20 meters? Not how long did it take to get there. It is, when is the height 20 meters? That means at all occasions. Okay, so again, we've got something that looks like this, and it occurs at, so I'm going to put the 20 instead. This will be in my y2. So this happens at t equals 0.242, and again at 6.758. And I'm just doing second calculate intersect.